It happens for less than 2 seconds. You walk into a room you've never been in, and your brain screams that you've stood in this exact spot before. Same light, same conversation, same feeling in your chest. Then it's gone. Scientists have been trying to explain this for over a century. And the real answer isn't mystical at all. It might be a glitch in the most important system in your brain. So what is actually happening in those 2 seconds? Let's start with the name itself, because even that has a strange history. The term déjà vu was coined in 1876 by a French researcher named Émile Boirac. He wasn't a neuroscientist. He was a philosopher studying what he called paramnesia, a fancy word for memories that feel real but aren't. For decades after that, the phenomenon stayed in the hands of philosophers and mystics. Sigmund Freud had his own theory. He believed déjà vu was a repressed memory clawing its way to the surface. Some buried experience your conscious mind refused to fully acknowledge. For most of the 20th century, that was the closest thing to a scientific explanation anyone had. A vague gesture toward the subconscious. But here's the thing. Nobody had any actual evidence, because nobody could make déjà vu happen on command. You can't study a feeling that vanishes in 2 seconds and never announces itself in advance. For 100 years, that was the wall science kept hitting. Then, in 1955, a Canadian neurosurgeon named Wilder Penfield accidentally found a crack in that wall. Penfield was operating on patients with severe epilepsy, fully conscious, with their brains exposed. Because the brain itself feels no pain. To map out which regions were causing their seizures, he touched different parts of their cortex with a small electrode. Most of the time, this triggered ordinary things. A twitch in the hand, a flash of light. But when he touched a specific region near the temporal lobe, something else happened. Patients suddenly insisted they'd been in this exact operating room before, that they'd had this exact conversation with him before. One patient described the feeling as overwhelming, as if her entire life were repeating itself in that instant. Penfield hadn't found a hallucination. He'd found a button, and it was sitting right next to one of the most important structures in your entire brain, memory. But Penfield wasn't the only one chasing this. A few years later, in 1963, a researcher named Robert Efron proposed a completely different mechanism, one that had nothing to do with memory storage at all. Efron's theory was about timing. He suggested that your brain processes incoming information through 2 separate pathways that are supposed to arrive at roughly the same moment, like 2 copies of the same signal sent through slightly different routes. Under his theory, déjà vu happens when one of those copies arrives a few milliseconds late. Your brain ends up processing the same present tense moment twice in quick succession, and because the second pass feels slightly delayed, it gets misread as a memory of something that already happened. For decades, this was known as the delay theory, and it competed directly with Penfield's memory-based explanation. Neither side had enough evidence to settle it. They were both staring at the same 2-second mystery from completely different angles. This is where the story gets interesting because it points directly at the hippocampus, the structure responsible for stitching your experiences into memories you can later recall. And here's where the real research begins. In the early 2000s, a French neuropsychologist named Chris Moulin started studying a strange category of patients, people who didn't get déjà vu occasionally. They got it constantly. One of his patients, a retired engineer he referred to in his research as AKP, told Moulin he no longer watched the news because every single story felt like something he'd already seen happen. He stopped reading books for the same reason. Every page felt like a memory. This wasn't a metaphor. His brain was generating the feeling of memory hundreds of times a day, with nothing behind it. Moulin scanned AKP's brain and found damage concentrated in the temporal lobe, the same region Penfield had been probing decades earlier. For Moulin, this confirmed something important. Déjà vu wasn't some mystical event. It was a specific, locatable brain process. And in people like AKP, that process had broken in a way that revealed exactly how it's supposed to work in the rest of us. So how does it work in a healthy brain that experiences déjà vu only once in a while? This is where a researcher named Cleary at Colorado State University changed the entire conversation. For years, Cleary had a problem. You can't study déjà vu in a lab if you can't trigger it, so she built a way to trigger it. Cleary used virtual reality to construct scenes that were structurally identical to other scenes participants had already seen, but never showed it to them directly. Same layout, Same spatial arrangement of furniture and walls. Different content entirely. A bedroom with a desk in the corner, for example, followed later by a garden with a bench in the same exact corner position. Participants had no idea the two scenes were related, but again and again when they walked into the second scene, they reported the unmistakable feeling of déjà vu. This was the breakthrough. Déjà vu wasn't being triggered by a memory of the actual place. It was being triggered by the underlying spatial pattern. Cleary's theory, now one of the leading explanations in the field, is called Gestalt familiarity. Your brain isn't comparing this exact moment to a stored memory. It's comparing the structure of this moment to the structure of a memory. And when the layout matches closely enough, your memory system fires a familiarity signal, even though the content is completely new. Here's the part that should change how you think about every déjà vu moment you've ever had. Your hippocampus has one specific job inside this process: pattern separation. Every single day, your hippocampus is bombarded with experiences that are similar to each other. Different coffee shops, different hallways, different conversations that all share a similar shape. To keep your memories from collapsing into a confused blur, your hippocampus has to constantly tag each experience as new, distinct, separate. That's pattern separation. It's running in the background of your mind every waking second, and you never notice it because it almost never fails. Déjà vu is the rare moment it almost does. Picture two photographs of two different rooms. They're not identical, but they're close enough that your brain's pattern separation system briefly hesitates. For a fraction of a second, your hippocampus essentially asks itself, "Have I already filed this one?" And in that instant of hesitation, a familiarity signal slips through. Your conscious mind receives that signal as a fully formed feeling. "I've been here before." Then, almost instantly, a separate part of your brain, your prefrontal cortex, runs its own check. It compares the moment against your actual memory banks, finds nothing, and corrects the error. That correction is why the feeling vanishes as fast as it arrives. You're not remembering a past life or catching a glimpse of fate. You're watching two systems in your brain disagree with each other for 2 seconds and then quietly resolve the argument. And this might explain something else that's puzzled researchers for years: why déjà vu happens far more often in young adults and then steadily declines with age. A 2003 review of dozens of studies found that déjà vu is most common between the ages of 15 and 25 and becomes rare after 60. At first glance, that seems backwards. Shouldn't memory glitches get worse as the brain ages, not better? But under the pattern separation model, it makes perfect sense. A younger brain is encoding new experiences at an extremely high rate, building enormous numbers of fresh, similar-shaped memories, which means more opportunities for two of them to almost overlap. An older brain, by contrast, isn't laying down nearly as many brand-new memory templates. Fewer near matches means fewer false alarms. There's another detail almost nobody mentions, and it might be the strangest part of all. Déjà vu requires you to recognize, in real time, that the feeling is false. That's an astonishing cognitive act most people never think twice about. You're essentially watching your own memory system make a mistake and catching it instantly, without anyone teaching you how. Try to imagine explaining that skill to someone who'd never experienced it. Sometimes my brain tells me something happened before, and somehow at the exact same moment, I know that it's lying to me. That's not a glitch in the ordinary sense. That's two extremely sophisticated systems checking each other's work, live, every single time it happens. Of course, science wasn't the only place people went looking for an explanation. Long before Boirac coined the term, cultures around the world already had their own answers for that 2-second feeling. In several Eastern philosophical traditions, the sensation was treated as residue from a past life, a flicker of a soul that had lived in that exact place before, in a different body, in a different century. In parts of medieval Europe, it was sometimes interpreted as a sign of prophecy or fate, evidence that your life was following a script that had already been written somewhere. Even today, surveys consistently find that a meaningful percentage of people who experience déjà vu privately wonder, at least for a moment, whether they just glimpsed something paranormal. That instinct makes sense. When your brain hands you a feeling this specific and this convincing, with absolutely no evidence to back it up, fate can feel like a more satisfying explanation than a momentary hiccup in your hippocampus. But the more researchers have studied it, the less room there is for mysticism and the more room there is for something arguably more interesting. A healthy brain, quietly checking its own work, thousands of times a day, almost never getting caught. Which brings us back to that room. The one you walked into, certain you'd stood in before. You hadn't. Not really. What you'd actually recognized wasn't the room itself, it was the shape of it. The geometry, the arrangement that your hippocampus had filed away somewhere else, in some other room, at some other point in your life, close enough in structure to brush up against this moment and spark a flicker of false recognition. For 1 or 2 seconds, 2 memory systems in your skull disagreed about whether this was new. And then, just as quietly as it appeared, your brain settled the argument and moved on, the way it has been quietly settling that exact argument thousands of times, your entire life, without you ever knowing the case was even open.